So today we're gonna solve a problem here, which basically is asking to find the mass of magnesium oxide. So what is the mass of magnesium oxide produced if 0.455 gram of sample of magnesium is allowed to burn in 2.315 grams of oxygen gas. Now the sole product is magnesium oxide. And it says after the reaction, no magnesium remains, and the mass of unreacted oxygen is 2.015 grams. And it's asking us to find the mass of magnesium oxide that is produced. Now you can use different approaches to solve this problem. I'll show you two of them, which are very simple. Before we go ahead and dive into the first approach, let's just recall and remind that the mass of substances or reactants before the reaction is always equal to the mass after the reaction, right? And therefore, we're just going to base on this idea to solve this problem. So approach number one is first we have to find what's the total mass, or first let's write here more. So I have the mass of magnesium, which is 0.455 grams, and we have the mass of unreacted oxygen after the reaction is 2.015 grams. We have the mass of oxygen before, let's write it after, A for after, B for before. It's 2.315 grams. Okay, now we're looking to find the mass of magnesium oxide. So what we have to do first is we have to find what was the mass, the total mass before the reaction. And you can find that by just adding the mass of magnesium, which is 0.455, with the mass of oxygen before the reaction, which is 2.315, which makes total mass, and that's B for before the reaction, which means 2.770 grams. That's total mass. Now total mass is 2.775. Now we can say that this relationship is valid, which this one total mass is equal to the mass of magnesium oxide as the end product plus the mass of oxygen. This is after the reaction. This is after the reaction. Okay, so A for after the reaction. You don't have to write A. I'm just writing here A just to make more easy for you to understand what I'm trying to say. Now, do we know the total mass? Yes, we know. This is very important. So the total mass is 2.770 grams. So this is 2.770 grams, which is, do we know the mass of magnesium oxide? No, we don't. So the mass of magnesium oxide is still unknown. Do we know the mass of oxygen after the reaction? Yes, we do, which is this one here, 2.015 gram. And now we do have two unknowns and one known. So this is pretty much easy to solve. The mass of MgO, magnesium oxide, is 2.770. Okay. So it's 2.770 grams minus 2.015 grams. that's equal to, okay, so this is 5, 5. Okay, this is 7, this is 0, so 0.755 grams. That's the first approach. Very simple. Now the second one, okay, so the second one is this one. So first, for the second one, we just write the chemical reaction. So the magnesium is a metal. Metals usually you don't see, or never you don't see in diatomic forms, just here alone. Okay, oxygen is a gas. Gases are always written in diatomic form, except noble gases. And the end result is MgO, and we have to balance it, so we have 2 oxygens here, 2 magnesium, so we have 2 magnesium. Now, okay, so let's see. So we have here the mass 0.455 grams, and it reacted with oxygen, and we don't know the mass of magnesium oxide. We know the molar mass of magnesium, so we can add it 2 times. Well, actually, just write this one here. 2 times 0.55, 2 times x gram. Molar mass, we don't multiply molar mass. No matter if you have a 2, you never multiply it. So that becomes only 24.3 grams per mole, equal to, that becomes 24.3 plus 16 is 40.3 grams per mole. Cross multiply, you'll get x equal to, okay, so this becomes 2 times 5, 10, 11, becomes 0.910 grams times we have 14.3 grams per mole, and we have 2 times 24.3 grams per mole. That's equal to, okay, so we have to do some calculation, bear with me. That becomes, okay, so 0.910 times 14.3, that is 366.73 grams per mole. Our cost of grams per mole, so we left grams. Okay, 2 times 24.3 is 48.6. So it's 366.73 divided by 48.6. Well, actually, this is 36. Sorry, 0.910 times 40. This is 36. Yep. So that's a mistake. So it's instead of 366, it's just, yeah, just let's move it 36.6. And the round is 0.75 grams. This is no gram. It's no gram. Only this is gram. 0.75. Also, you can find this 5 because it's the same. But yeah, this is the second approach. Whichever you feel more confident, you can use this. Either the first one or the second one. Both are accurate. Okay, I'll see you in next one. See, bye bye.